So this will be class 6 of our data science and machine learning tutorial series, and today we are going to be talking about classification. Of course, I'm talking about data science and machine learning as synonyms. So for now, or for a second, let's assume that these are the same thing. So here we have, let me just explain to you, data science or machine learning is divided into two parts. We have supervised learning and unsupervised learning. And for supervised learning, we have classification and regression. Okay? So this is where we are. We are still under supervised learning, and now we are delving into classification. So let me mark down this cell so that I can use it to explain. So I'm going to just go to heading 1, and then I'm going to mark it down. All right. So what is classification? I already have explained it in my website, so you can actually read the theories. But basically, in this class, we are going to be building a classifier. We're going to discuss classification, build a classifier, and evaluate the metrics of this classifier. So in simple terms, classification says that if you are given a data set, simply find the relationship between the predictor variables and the predicted variables. What do we mean by this? So assuming you have x1, we have x2, we have y, such that we have 2, 2, 3, 1, 2, 4, and so on. We have 3, 6, 7. We have this data set. Somehow you want to determine the relationship between x1, x2, and y. So basically the intuition is this. The intuition that is that f of x1 and x2 is equal to y. So meaning that given x1 and x2, you can deduce y based on x1 and x2, which means that x1 and x2, they are the independent variables, also called predictor variables. And y is the dependent variables called predicted variables, because we are going to predict the value of y based on x1, x2. So the question now is, what is this function? Is it x1 plus x2, or maybe 2x1 plus 3x2 is equal to y? We don't know what this function is all about. So when we are building a classifier, we are trying to determine the nature of this function. We are trying to deduce this function. So basically, let's take a simplistic case now. So assuming that we have x1, we have x2, and we have, let's say we have y, and we have, let's say 2, 1, and we have 4. Let's say we have 1, 1, and we have 3, and we have 3, 1, and here we have, let's say, 5. All right. So if I'm given a new value, how do I determine? For now, I know that y is equal to f of x1 and x2, and y is going to be x1 plus x2 plus 1. So if you check it now, you have 2 plus 1 plus 2 plus 1 plus 1 is going to be 4. 1 plus 1, 2 plus 1 is 3. 3 plus 1 is 4 plus 1 is 5. So I've intuitively, because I'm very smart, I have determined that the function is x1 plus x2 plus 1 is equal to y. Now there are many x, x1, x2, x3, x4 to x100 or x50. You cannot intuitively do this. You can't look at this data like me now and just do it. You have to use a model to do it, and that's what we do when we are building a classifier. We are trying to determine this function of x and y, or this function that relates the x and the y variables. So we call the x's, we call them the features, and the y, we call it the classes. So we are trying to determine, given series of x, we want to determine the class it belongs. In this case, y we call the classes. And here we have, how many classes? We have 3, because 3 classes here, we have 4, 3, 5. There are 3 different classes. So in this case now, assuming I'm given a new data set, this data set that is new, we call it the test data set. The data set that has values is called a training data set. So the test data set is something like this. Let's say we have 6, we have 1, and we have question mark. Okay, so this now is what we call the test data set. And in this case, in this simplistic example I have here, I have 3 training data set, 1 test data set, and we got to predict what the test data set is all about. the value for the test data set, or the value of y given the test data. Okay. So, so in this case, we have how many? We have 4 items. So we have the test data set here is 25%, and how the training data set is 75% of the data, right? But in case of the test data set, you might have an existing value, but you have to predict. When you predict, we now have to compare it with the value that is already there. For now, in this case, the value is 7. And we'll build a classifier. The classifier may predict maybe 6.9 because it's a classifier. It's going to use an algorithm. And then you want to compare to 7 and see it is very much closer to 7. So it's a bit accurate, but not very accurate. Okay, this is enough of talking now. Let's go to solve problems. Let's now build the classifier right from the scratch. So I'm going to make a shift here. I'm going to use this. Okay, so we are going to build a classifier called newbies classifier. So I'm going to start immediately. Now this is the steps to follow. So permit me to kind of put the steps side by side. Alright, so I'm putting the steps side by side with our tutorial. So of course I already know it. So for you, it's better you use it side by side and also kind of type out this code by yourself. Don't copy and paste, just type it out. So the first thing you want to do is to import. We're going to be using the data set called the breast cancer data set, which is available in SQL the data set. So I'm going to first import my models. I'm going to say import skline.dataset as ds, and I'm going to import pandas as pd, and I'm going to import numpy as np, import numpy as np. So let me kind of increase the size of this a bit. Increase like this. Great. Alright, so now I'm going to run. Okay, everything is fine. Now I'm going to load up the data set into an array. When you import a data set, that data set comes as an array. So I'm going to call it BC for breast cancer. BC array. So the array is equal to ds.load and ds.load. So this is the syntax to load this very data set. Okay, so when I load it now, I'm going to run and it's run. So if you want to see this data set, you can simply type it out like this BC underscore array. And still have the data set here, but it doesn't make sense. We're going to split it out. Now you have the target. The target is like the classes or the y values, and the data, which is what you have here, is the x values that we mentioned. And we are going to see what this is all about in a minute. I'm going to clean up this data. Of course, you've learned about data cleaning and data pre-processing in the previous class. So if you've forgotten, please go back and check. All right, so I'm going to now say features is equal to BC array. BC array is data, because the BC the data key contains the features or the x values, and the y, which is classes, is in the features, I think. So I could copy and paste. Actually, it's target. Okay. So we also have the feature names, which is actually the feature names of these features. Now, you don't call it x1, x2, but they have names. So I'm going to extract them as well, because they are also available in the feature names key. So I'm going to say BC array. This time it's going to be feature underscore names. As I mentioned, the best way to learn is simply to type it out. So don't copy and paste, and this is exactly what I'm doing now. And we also have the column names. Column names now is pending the feature names and the column name class. So I have x1, x2, x3. Instead of using y, I'm using class. right? So we have the feature names, and we have, I don't know, I don't have my OneNote open now. So I'm going to show it up later on so that you understand what happens. So I'm going to say np.append. So I'm going to append feature column names. Give me 1 second. Okay, so it's going to be feature names. I think I made a typo there. Feature names and class. Okay. So this is feature names is going to be second feature names. Yeah, so there's going to be feature names. Okay. And then column names is all the columns. Feature names is the column names for all the features. We have appending the class as a string, as adding it as a feature to the feature existing feature names. And I'm going to now run this and make sure everything is fine. So I have a typo here. Okay. So, feature names is not defined. Feature names is going to be like this. Okay. Alright, so we should be fine now. I'm going to now create a new data frame. I'm going to call it bcdf is equal to pd.dataframe. I'm going to give it the data to be np.c, C for concatenate. So I'm going to concatenate the feature and the classes, concatenate the features and the classes. And then I'm going to specify the columns is equal to the column names. Okay. Let me just check that I'm not making a mistake. Okay, there should be a mistake somewhere. I'm going to put a closing bracket here and let me run. Okay, perfect. So what happened here is I'm creating a data frame, and the data for this data frame is going to be concatenation of the feature and the classes. Remember when we did the iris data set, the features is the four variables, the sepal width, sepal height, length, petal width, petal length. These are the four features. I'm concatenating now with the classes, and the iris data set is going to be the classes, which is setosa, vesicle, and vaginica. In this case, the classes is this target right here. So I'm concatenating the feature and the classes to give me just one large data frame instead of to have two separated data. So if I look at this data frame now, the data frame I built up now, so I'm going to say BC, DF, and let me see. Alright, so we have our data frame, we built it up. So let me scroll this way to just see what the class is all about. You can see the classes right here. The classes is just 0 and 1.0. I think is 0 and 1. So it's just two classes, 0 and 1. So you can see 1 here. So if I say bc underscore df.tail, and you can see we have, scroll this way, you have 1 here, but I would like to kind of see the two classes there. So I'm going to say bcdf.iloc. I'm specifying give me 1 sec. Okay, so I'm going to first say bcdf.shape. Okay, the shape is not callable, so I'm going to just use it. So we have 31 columns. So it means that if I say bc underscore df .iloc, I'm going to specify a comma here. Taking all the rows, which is from row 0 to the end, and taking column 31 to the end, I think. So I'm going to check it out. Okay. Okay, yeah. So column 30 to the end. So 31 is not inclusive, so it's going to be 30 to the end. And let me just check if I can change this to a set, if it's going to work. I don't know. So I'm going to hit this key. Okay. Okay, so that is what I wanted to achieve. I wanted to see the two distinct values on the classes. So you have two values, only two classes there. We have 0 and 1. So two classes. We want to classify, given a set of 31 features, we want to classify it into 0 or 1, maybe male, female, but we don't know. Alright, so how about data set? And we've actually done obtained our data set. We've kind of created our data frame. We want to now split this data set into train and test data set. You already learned about this before, so I'm going to just do it here. So I'm going to say split into train and test. So this is an aspect of pre-processing. I'm going to kind of mark it down to cell 4. Okay. So to split into train and test, we need to import the train test split coming from sklearn.model selection. So I'm going to say from sklearn.model underscore selection import train test split. Alright, so this is fine. Let's see. sklearn. Okay, so my CPU fan is freaking out, so I think I'm just going to kind of copy and paste and then explain it to you. So we are splitting this data into two parts, the training set and the test data set. So the training set is the label data, and the test data set is the test where we more or less will remove the labels and allow our classifier to do the prediction and later check if it predicted correctly. So we are creating X train, X test, Y train, Y test. So X train and Y train is simply the X train and Y train is simply the training data set, which is about 70% of the data is going to be training data set, and 30% is going to be for tests. Remember, I showed you that when we did it in our OneNote, we had 25% to be for training and 25% for test. In this case, we have 4 items. We are using 1 for test. But in this case, we want to use 70% for training and 30% for test. Now you already know that we have the tests. X and Y is simply the X and Y. The Y is the classes. The X is the features. So I'm going to run this now and says invalid what? See, challenge here. Maybe I don't need to have, okay. Alright, so I'm going to build a classifier now, and the classifier is going to be a name-based classifier. So I'm going to import Gaussian name-based from sklearn.base. So I'm going to import from sklearn. Again, type this code out yourself. The more you type, the better. Name base. Import Gaussian name base. I'm going to create a classifier object. I'm going to call it GNB is equal to Gaussian NB, and then I'm going to fit a model through the training data set. So I'm going to create a model. Say GNB.fit. And I'm going to give it the training data set. So I'm building the model and using the training data set to train this model. So it's going to be X train and Y train. Hopefully it works. Okay, it gives us an error. Gaussian name base is going to be a function called like this. Okay. So we built our model now using the training data set. We now want to give it some test data to allow it to predict and see if it predicts correctly. And yeah, so we are going to now say from sklearn the metrics. So we are trying to give it a test data set and allow it to make prediction. And once it makes prediction, we're going to check how accurate the prediction was, as we discussed earlier on. So I'm going to import accuracy score. I'm going to import accuracy score and do a prediction. I'm going to predict Y. Y predict. I'm going to call it Y predict. So given X test, predict Y, and then we're going to compare your Y predict with Y test, because now we are giving you X test and predict Y. So once you predict Y, what we want is so that the y predicted is going to be close to or exactly the same as the y test. But now it's not going to be exactly the same. There'll be some errors, and we're going to calculate how accurate the classifier performs. So I'm going to say GNB.predict, and I'm going to give it X test, and it's going to make a prediction. I'm going to run, and now let's check the accuracy by printing the accuracy. This time I'm going to use the predicted value and the actual value, which is y test, to do it to check the accuracy. So I'm going to say accuracy score. I'm going to give it the y test, which is the actual value. I'm also going to give this accuracy score the predicted value, which I call the y pred. And we want to now see the accuracy of this classifier. I'm going to have one more bracket here to close. Okay, so our classifier here is 93% accurate, which is fairly okay for normal applications. It's 93% accurate. So what does this accuracy mean? It means that it's got 93% of the predictions are correct, and about let's say 7% or 6.7% is wrong. Alright, so what are other evaluation metrics for a classifier? Accuracy is just one of them. So we have 4 different evaluation metrics. We have true positive, false positive, true negative, and false negative. Now in this class, in this data set, we have 0 and 1. So if there is a classification made and the actual value is 1 and the classifier predicted 1, that's a true positive, that's great. But however, if the actual value is 0 but the classifier predicted 1, that is a false positive, right? So because 1 is positive, 0 is negative. So that's how we have a 2 classes classifier. We have 0 or 1, we have negative and positive, and stuff like that. Okay, so true negative is when the actual value is 0 and the classifier predicted 0, that's a true negative. And false negative is the actual value is 1 and the classifier predicted it to be 0. That's wrong, that's false positive. Now the confusion matrix gives us the value of these 4 different metrics is provided by a confusion matrix. And I'm going to just display the confusion matrix, and then we see the numbers of the true positive, true negative, false negative of our classifier. And the idea is that we want to reduce false negative, right? Sorry, let me just get it right. We want to reduce false negative to the minimum, right? So false negative is when the actual value is 1, but it's predicting 0. So meaning that someone has cancer, in the case of cancer diagnosis, and you are predicting negative, whereas there is cancer. This is type 2 error. If it happens, it's really so bad. So if there is positive, there's cancer, actually the person has cancer, but the classifier predicted negative. That's a false negative, and that is so bad. That's a type 2 error. However, if the person does not have cancer, that's negative, but the classifier predicted that he has cancer, and that is false positive, that is also bad. But not as bad as when someone has cancer, is predicted as not having cancer. That person may die because he will not be treated, and that's why we call it the type 2 error. So let's display the confusion matrix. So I'm going to say sklearn.metrics import confusion matrix. And I'm going to display the confusion matrix now. Confusion matrix underscore matrix. I'm going to give it the y test as well as the y pred. Now we have our confusion matrix. What does this mean? So the confusion matrix gives us in this case we have there's a true positive. Let me just get it right. So we have true positive, false positive, true negative, true. So the first item in the confusion matrix is the true positive. All right. The last item in the confusion matrix is the true negative. Right. So the bad one is this 6, which is false positive and have false negative. So I have true positive, false positive, or true positive, true negative. I can't remember exactly. You can check. I'm going to clarify about the confusion matrix later on after now. But for now, try to read it up on my website. Also, try to read up the explanation right here. So I'm going to be stopping here, and hopefully you understood what classification is all about. In the next part, we're going to be looking at logistic regression. And logistic regression is also classification, because although it's called regression, but it's classification. And then we are going to be looking at an exercise where a real company gives us a data set and want to advise them based on their data set. Alright, so I'm going to stop here. We've actually reviewed classification, built name-based classifier, checked the accuracy of the classifier, also displayed the confusion matrix. We talked about the metrics like the true positive, the false positive, the true negative, and the false negative. We talked about the type 1 and type 2 error, and that is so fine. So I'd like to thank you for viewing. This is class 6 completing now. And please remember to subscribe if you've not subscribed to my channel. And if you are joining for the first time, please go back to review the classes from class 1, because this is a continuous series. And I remain Kind on the Tech Pro, and I'm always there for you.